Welcome to SOL topic number 10, normal distribution and z-scores. For our normal distribution, you must remember the empirical rule, 68, 95, 99, 7. This will help you with your percentages. Here's an example of our normal curve. The mean is exactly in the middle right here at 0. If we go one standard deviation above the mean and one standard deviation below the mean, then we will have 68% of our data in between -1 and +1. If we go two standard deviations above the mean and two standard deviations below the mean, then we will have 95% of our data in between -2 and +2. And if we go all the way up to 3 standard deviations above the mean and 3 standard deviations below the mean, then we will have 99.7% of our data. Roughly all of our data will lie in between -3 and +3 standard deviations. A z-score is a measure of how far a data point is away from our mean. Remember, the mean is exactly here in the middle, so a z-score for the mean is exactly 0.00. You will need to be able to calculate z-scores, so we will give you this formula on your formula sheet, and here it is. The z-score equals x minus mu divided by sigma. X represents your data point, or your data value. The mu represents your mean. On the calculator, you're going to see it as an x with a bar, and sigma represents your standard deviation. On your calculator, you're going to see it as sigma of x. So those mean the same thing. So we'll practice calculating our z-scores. For normal percentiles, we will be using our z-score chart. To determine the probability or the percentage of something occurring, you can use our z-score chart, and we can, once we determine what the z-score is. So for example, if we're looking for the probability or the percentage of something occurring that's below, we will calculate the z-score and simply look at the table, because the table will give us all of the values that happen below what we're looking. So the table will give you the probabilities, for example, 0.8289. If you want to convert it to a percentage, of course, just move the decimal point 2 units, and we have 82.89%. So it just depends on which of the numbers you're talking about. So that's below. If we're looking for the probability or the percentage in between two data values, then we will calculate the z-score for each of them. We will look at the table for each of them, and then we will simply subtract those two either probabilities or percentages, bigger minus smaller. And finally, for the probability or the percentage above, remember, the table always gives you the stuff below. So when we calculate the z-score and look at the table, we need to take that percentage or that probability and subtract it from 100% or from 1. So we'll look at how to use the table as well. Let's look at example number 1. A normally distributed data set, now you're going to see these buzzwords when we're talking about normal distribution, of course. A normally distributed data set has a mean of 20, so I'm going to mark this as my mean with both of my symbols, and a standard deviation of 5, so I'll go ahead and make a sigma, or maybe sigma of x, which is closest to the percent of values in between 10 and 30. All right, so one way to solve this, I'm going to draw a picture of our normal curve. Nice and symmetric curve here. Right here in the middle is our mean, and I know that that's 20. Since I know what my standard deviation is, which is 5, I can start adding that to get above the mean. So this would be 25, and this would be 30, and this would be 35. I could start subtracting my standard deviation to get below my mean, so 15 and 10 and 5. Now I'm asked to find the percent of values in between 10 and 30, which I can see now are right here and here. So we're talking about these 4 regions of our normal curve. The percent of data here, 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 and here all together. Well, you can see that 30 is exactly 2 standard deviations above my mean, and that 10 is exactly 2 standard deviations below my mean. And from our empirical rule, this represents 95% of our data. So we have our answer, D. Another way to solve this, instead of drawing your picture here, you could calculate each of the z-scores for your 2 data points. So let's just show you that. Let's draw z equals, I'm going to take my data point, which is 10, subtract my mean, which is 20, and divide by my standard deviation, which is 5. This will find one of my z-scores. This is negative 10 divided by 5, which is negative 2. My other z-score is found using the same exact formula, but a different data point, the 30 this time. So 30, take away the 20 divided by the 5. This time z would be 10 divided by 5, which is positive 2. So I'm looking for the percent of data in between a z-score of negative 2 and positive 2. And again, from our empirical rule, in between negative 2 and positive 2 is right here, 95% of our data. Let's look at our second example. Based on our normal model, now that's another way of saying that we're talking about a normal distribution. The normal model for snowfall in a certain town, there is a mean of 57 inches, so let's label that with our mean symbols, and a standard deviation of 8 inches. So here's our sigma, or sigma of x, like the calculator will show. How many inches of snow would represent the 25th percentile? Okay, so if we're talking about percentiles, then we're using our z-score chart. Now, when we're using our z-score chart, we're basically needing the z-score. So I'm going to write the z-score formula down. Z equals x minus mu divided by sigma. Now, I know my mu, and I know my sigma, but I don't know my data point. It's going to be one of these 4 answers, of course. And I also don't know my z-score yet, but I do know it's a z-score that represents the 25th percentile. Let me show you how to find this from our chart. So let's pull out our chart. Right now you're looking at the positive side of our z-score table, and you're looking at, since we're looking at the positive ones, we're looking at all the percentages that are above 50%. Here, right here at 0, 0 is exactly 50%. I'm not interested in 50% or higher. I'm interested in 25% or the 25th percentile. So I do need to flip over or scroll down to the negative side of our z-score table. These are all the percentages that are below 50%, or rather the probabilities that are below 0.5. I want to find the probability that's closest to 0.25. So I'm looking here, here's 0.10, 12, 16, 19, let's see, I'm getting, oh, here we go. Now I'm not going to get exactly 0.2500, but I do see the 2 probabilities that are in between, or where 0.25 would be in between. So 0.2483, now 83 is 17 away from 100, and 0.2514, 14 is 14 away from 100. So since 14 is a little bit closer than 17, this is the probability that I'm going to use for the 25th percentile. This is close enough. Now I need to figure out the z-score for this cell, for this probability. Well, the z-score comes from the column over here and the row up at the top. So this cell has a z-score of negative 0.6 and then 7. So that's my z-score, negative 0.6, 7. And now I'm finished with my table. I know my z-score is negative 0.67. I still don't know my data point. That's what I'm going to be finding. My mu was 57 from my problem, and my sigma was 8 from my problem. So now I'm just missing x. Now you could take each one of these answers and plug them into this equation and see which one gives you negative 0.67. That would be fine. I'm going to simply solve this equation to practice those skills. I'm going to multiply by 8 to get rid of my denominator. 8 times negative 0.67 gives me negative 5.36. And then my numerator just pops on down, x minus 57. Now I just need to get rid of this negative 57, so I'll just add 57 to both sides. And I'll have my data point x is 51.64. So that should be my answer. Let's see. Looks like they've only rounded to the tenths, so 51.6 must be my answer. So thanks for watching this tutorial on SOL topic number 10, normal distribution and z-scores, and have fun working on the other examples from our practice packet. See ya.